We're going to do some reviewing here, lessons 8.1, 8.3, 8.4, IN5, IN6, IN7. On page 448, we've got a little bit of reviewing with lesson 8.1. Remember lesson 8.1, we skipped some of this stuff because some of this was not part of your 8th grade math standards. Given a formula, we should be able to do any of these problems, but we're just going to focus on number 2 because surface area of a sphere is one of the 8th grade standards. So surface area of a sphere, this formula would be given to you. Surface area of a sphere is 4 pi r squared. Watch the directions here. They want you to do this in terms of pi. So when you're doing these, you know, sometimes they'll say in terms of pi, sometimes they say use 3.14 for pi. If you're doing this on the iLearn test, you've got a pi button there on your calculator, and you should be able to use that. So this one in terms of pi, we'll keep the pi there. This, you can see they gave us the diameter was 10, means the radius is 5. So 5 squared, 5 times 5 is 25. And then we can go ahead and multiply 4 times 25 is 100. So 100 pi square centimeters would be surface area in terms of pi. We skipped lesson 2, volume of cylinders. Again, that was a 7th grade standard. With the formula we could do it, but that's not what we're going to be tested on here. Lesson 3, volume of cones. So number 1, they want the volume of the cone in terms of pi. Again, formula would be given for you here, 1/3 pi r squared h. It says in terms of pi, so we're going to keep the pi there. This time they gave us the radius, which is 3. They gave us the height, which is 8. So 3 squared, 3 times 3 is 9. 9 times 8 is 72. And we can put that over 1. If you multiply straight across, you get 72/3 pi. And if you take 72 divided by 3, then you get 24. So you might have done that in a slightly different order, but in the end, in terms of pi, it should be 24 pi, and that would be cubic inches if we want to put units, cubic units for volume. Number 2, similar idea. On this one, they want us to use 3.14 for pi. So start with your formula, 3.14 for pi. Radius is 4. Oh. Okay, here we got to be careful. The 5 is not the height. Height goes straight up and down. So what we have to do here is use Pythagorean theorem. A squared plus b squared equals c squared. Hypotenuse, the longest side is always across from the right angle, which would be the 5. So height is one of the legs, the other leg is the 4. So 4 squared is 16, 5 squared is 25. And if you subtract, so subtract 16 on both sides because they were adding, and then they're squaring, take the square root, and we'll get our height to be 3. Now that we've got our height to be 3, we can substitute that in the formula. Uh, 4 squared is 16. We can put all these over 1. Anything, if you're multiplying all this together, you can actually cancel those 3's out if you want. Numerator and denominator, since we're multiplying, those are like factors that can be reduced. Anyway, you work this all the way out and you should get 50.24 cubic centimeters. And again, you can multiply just straight across and then divide that out. You should get the same answer. Lesson 4, volume of spheres. So if we look at number 1, they want us to use 22/7 for pi. So formula for that, again, would be given like all these other formulas. 4/3 pi r cubed. If we use 22/7 for pi, radius is 14. Order of operations, first thing we would do would be to take care of our exponent, so 14 cubed. Number 2, surface area of a sphere is given, and they're asking what the volume of the sphere is. So we can use both of the formulas for that. So start out with your surface area formula, which is 4 pi r squared. They give you the surface area. It says use 3.14 for pi. And if we work this out, we'll be able to figure out what the radius is. So cleaning up on the right side a little bit, multiplying those would be 12.56. At that point, they're multiplying, so we can divide by 12.56. When you divide that, all of a sudden it looks really nice here. We have an 81. They're squaring, so we can take the square root. Technically, we should add plus or minus. I know it's never working on these situations, but if there's a situation where it just says solve the equation, we need two answers. If it just says solve this equation and we don't know, and it's not a radius, that has to be positive. So radius is 9, and then we can substitute that into our formula. We're using 3.14 for pi. So that's 729, and then we can multiply this all out. So that would be 9,156.24 over 3. And then when you divide that out, you should get 3,052 800 cubic inches. And number 3, volume of the composite figure. So we have two separate pieces here. We have the top part, we can call a hemisphere or a half sphere if you want. And then we have the cone. So the half sphere, for a sphere where volume is 4/3 pi r cubed, for a cone is 1/3 pi r squared height. What I'm going to do is just save my pi. Diameter is 4, means the radius would be 2. 2 cubed, 2 times 2 times 2 is 8. And if you multiply, just keep the pi there. This would be 32/3 pi, and here's an example of maybe what not to do. I forgot to figure up that we were just doing half of a sphere, so I just did a sphere there. So really best would probably be to go ahead and put the half at the beginning, so you make sure you don't forget about that. So that'd be 32/6 pi. Or you could reduce that to 16/3 pi if you want for the hemisphere. For the cone, so radius is 2, and the height is 10. So 2 squared, 2 times 2 is 4. Put those over 1. So that'd be 40/3 pi. Okay, and by saving the pi, what we've done is we've made it to where we don't have to worry about the decimals and stuff. Once we get to this point, we add those together, would be 56/3 pi. And at that point, we'll go ahead and substitute in 3.14 for pi. Multiply and then divide that out, and you should get 58.61 cubic centimeters.